Alright, this lesson is 7.9. We're going to be identifying equivalent expressions. So starting with example 1. Determine whether 10t times 4 is equivalent to 14t. So we've just got to decide, is this equivalent or not equivalent? So in order to do that, let's break this down. Here we have 10t times 4. Here we have 14t. If I were to simplify this, what's 10t times 4 going to be?
40t.
40t. Is 40t equivalent to 14t? It's not equivalent. So to show non-equivalent with a sign, you'd put an equal sign and put a line through it. And we'll write not equivalent. Does that make sense? Remember, you can multiply a coefficient and a variable times a number, but you can't add it. So like terms, you can, to add or subtract, they have to be like terms, but you can multiply. All right, look at example 2. Go ahead and write that down. Okay, so we have 7y plus the sum of x and 3y, and we have 10y plus x, and we've got to decide whether these are equivalent or not equivalent. So one thing we're going to do first here is we're going to use our associative property to regroup these. When we've got addition, we can regroup these as we need to, right? Because there's no multiplication happening here other than what would happen between the coefficient and the variable if we were solving, but we're not solving here. So I'm going to put my y's together. So when I regroup it, I'm going to put my parentheses around my y's. So now, can I add my y's? And what would that give me? 10y plus x. So are these equivalent? They're equal, right? So these are equivalent. Does anybody have a question about that? I can pause it if you have a question, if you raise your hand. All right, so let's look at example 3. We have 10 times the sum of m and n, and we have 10m plus n, and we've got to decide whether these are equivalent or not equivalent. So this time, we're going to apply the distributive property. So we're going to take 10 times m, and what else? 10 times n. So 10 times m is 10m plus 10n. Are these equivalent? No. So these are not equivalent. Do you understand why they're not equivalent?
Yes.
Do you see how using the properties can help us?
Yes.
Helps us with, over here on the board, notice I've got the yellow, green, and pink. It's got those properties. Notice for the associative, I've got the word regroup because it means you're just regrouping your like terms. For the commutative properties, you're reordering, so you're putting your terms together. And the distributed, there's an example of how we do that. All right, let's go ahead and look on page, go ahead and turn in your books to page 285. Page 285.
I flipped to this page a minute ago and it isn't, and I was like, no, you skipped a lesson. And then I flipped back and I'm like,
You do realize that I'm still recording, right? So
no, I didn't realize that.
everybody that's watching this video will.
I could care less.
Okay. Number 1, we've got to decide whether 7k plus 4 plus 2k and 4 plus 9k are equivalent. So we're going to start by using the commutative property to regroup them so that we can put our like terms together. So I'm going to put my K's together. So what I just did there would be the commutative property. Now, grouping them, like if I were to go back and put parentheses around my like terms right there, that would be using the associative property. So then when I put these together, 7K and 2K, I get 9K plus 4. And then if I wanted to turn it around, I could. Right? So are these equivalent or not equivalent?
Yes.
These are equivalent. So just use the word equivalent. All right, look at number 2. Can I multiply 9A times 3? I can. If this was addition, I couldn't add them, but I can multiply them. Okay, so what's 9A times 3 going to be?
9 times 3 is
27A. So are these equivalent?
Yes. No.
No, so this would be not equivalent. Remember, you can multiply or divide terms, you just can't add or subtract them. I'm sorry, let me clarify. You can multiply any terms together. You can only add or subtract like terms. So if they're not alike, you cannot add or subtract them, but you can still multiply. That's part of the rules of math. You with me, Robbie?
Yes.
All right, look at number 3. We have 8p plus 0 and 8p times 0. Can I add 8p and 0? No, because they're not like terms. Can I multiply 8p and 0? And what would that be? 0. So are these equivalent or non-equivalent? Not equivalent. Now, if I knew what P was, I could work out the whole problem. But until I know what P is, I can't work out the whole problem. All right, look at number 4. So we're probably going to have to work with both of these. So let's go ahead and use the distributive property here. So we're going to say 5 times A, which would be what? 5A, plus 5 times B, which would be 5B. All right, so over here, I've got 5A plus 2B plus 3B. So let's put these together. So 5A plus, what's 2B plus 5? 2B plus 3B. 5B. So what can we say about these?
Wait.
What do we think?
Wait, they are equivalent.
These are equivalent.
5A goes with 5A, 5B goes with 5B.
Okay.
Oh.
Do you understand?
Yeah, I didn't see the one over there. I just now saw it.
Okay. All right, so what we're going to do next, I'm going to let you do 5 through 10 on your own. Then you're going to bring it to me and let me check it. Okay? And then we'll do our exit tickets. Okay.